Good morning slash afternoon for wherever you are stationed currently, but we're just gonna give one more minute for everyone to join back in. Just wanted to give a quick housekeeping kind of item real quick. So throughout the length of the presentation, there's an area at the bottom of your screen to have a Q&A. And so if you have questions throughout the presentation, please feel free to ask those and we'll get those answered at the end of the end of our time here today. So I'm all going to get started here in about a minute and then we'll kick everything off. Alrighty, guys, I'm going to go ahead and get started today. It's 12 on the dot, so we're going to get started. And so thank you for joining us today. I'm very excited to bring this webinar to you guys. I'm really focused on how we can boost the leak detection efficiency, specifically using satellite technology. So on the webinar today is myself. I'm John Stevens. I'm the Territory Sales Manager for Astera, covering everything in the Eastern United States. I've been with Astera for about 4.5 years now, really helping utilities on the Eastern United States really address their water loss efficiently, utilizing a satellite guided method to do so. I'll be joined today by Mr. Paul Gagliardo. He's the principal consultant of Gagli Aqua Consulting and also the host of the Water on Stream podcast. Been in the industry for a very long time, has a ton of knowledge as well. Now, going through a quick agenda for you guys today. So we're going to first start off with some of the operational challenges that utilities do face. We're going to go through how we can increase the efficiency of leak detection utilizing satellite technology to really guide that attack. Then we're going to go through some benchmarking metrics for comparing it to the performance because it's not an apples to apples. So we need to look at different metrics to really compare the performance of the two methods. And then we'll go through some applications beyond just the potable water systems that Astera has solutions for. And then I'll hop into also some real world examples for you guys through 3 case studies spaced throughout the United States for you. So now I'm going to toss it over to Paul to really talk about why we're all here today in the water loss problem that we're all facing. So Paul, take it away.
Yeah, thanks, John. Hi, everybody. We all know water loss is a big problem. We all know that our potable water system infrastructure is aging and that our underground pipes are leaking. The Utah State University reports every few years on water main breaks in the United States and Canada. The latest report collected data on 800 utilities with over 400,000 miles of pipelines. They self-reported an 11.1% leakage rate, which personally seems low to me. In my experience, leakage rates average around 15 to 17% and can go as high as 40 to 50%, especially in some small rural systems. And if there's not a proactive leak detection programs, these levels continue to rise. Without a proactive program, leakage rates can increase by 2 or 3 percentage points a year. The report also mentioned that there were 11 water main breaks per 100 miles of pipe per year. These are only the main breaks that surfaced. There are many more leaks that do not surface. I would say 60 or 70% of all leaks found by satellite imagery leak detection are non-surfacing. And there are at least twice as many leaks on surface lines as there are on main lines. It's been estimated that it'll take $420 billion over the next 20 years to fix and maintain pipelines. Utilities spend more money on fixing and replacing pipes than on any other budget line item. It's a big problem, and you can compare your system performance to this set of average data. John, next slide, please. So why do utilities perform leak detection? There are many issues facing utilities these days. Leaking pipes and aging infrastructure are just two of them. Utilities may be required to reduce non-revenue water from regulatory mandates because of water supply shortages or due to cost considerations. And utilities may have their own water loss reduction goals. There are many options out there for utilities to consider, so it's difficult to decide how to tackle this problem. Reliable information on leak detection solutions can be hard to come by. Many technology providers do not publish data on performance, so one must rely on anecdotal data for comparison purposes. This separates Astera from the pack in that they are continuously reporting performance by writing case studies, presenting at conferences, and writing articles for publications in magazines. Operators and engineers must educate themselves on the technology, capital and operating costs, and the performance of various available solutions. Ultimately, the value proposition of a solution should be known before it's deployed. Not only that, but there are funding, staffing, and training issues that utilities must cope with. Long-term employees are retiring and institutional knowledge is being lost. Budgets are getting tighter. We must all do more with less. And all technology requires training so it can be used more efficiently. I'll now pass the baton back to John so he can describe how the SILD remote Earth observation solution works. John?
Thank you, Paul. Alrighty, guys. So now I'm going to go through really, like Paul mentioned, the satellite imagery leak detection technology. Aster is one of the sole providers of that currently. And so what we what we are doing is really taking synthetic aperture radar. And so it's actually an application that's been around for a long time. And I'm making it actionable for you guys to really go out and make it more real world actionable to go out and find some leaks for you. So since we launched back in 2013, we've been able to verify around 191,000 leaks worldwide. And I've also been able to save the world about 641 billion gallons of water. Now, how satellite detection works, it's really a step-by-step process from view, analyze, to identify. And so the first step, like I mentioned, is the view, where we take that satellite image, capturing really the entire system right there itself. And so it's one of the benefits, as you can already think about efficiency increases, we're able to now scan that system multiple times throughout a year period for you guys. How we analyze that is, like I mentioned, we have patented algorithms all based on that synthetic aperture radar and the use of L-band on that radar wavelength. And so the one thing that the satellite detection can actually do is it can actually identify the unique signature of potable water in the ground, in the soil next to your pipes, which is almost always identifying a leak right there. And then we're able to get that data back to you guys and have it be actionable for the crews to go out and then verify those leaks inside those areas right there. Now, how that process works, really a step-by-step comparison or timeline of image acquisition all the way to excavation as well. And so with satellite imagery leak detection, it is a collaborative process. So we still need the other method of pinpointing to go and do so. And so steps 1 and 2 are the satellite imagery leak detection side of things, where we can take an image of the entire system, analyze that, and provide these areas where we already see the potable water leaking. Step 3 and 4 is when we have a very trained team go out there, and we're going to go into these points of interest and go and verify where that leak is occurring. Because with satellite imagery leak detection, we see where the water is accumulating in the soil, not on the pipe itself. And so that's why we need that other team to go back in there and then just verify where exactly that leak is originating on that pipe for you. And so, like I mentioned, it's really all about the efficiency of leak detection, how we can really make the most out of your limited resources, limited staff, limited funding, all of that stuff as well. And so if we're looking at a traditional, say, point-to-point survey when it comes to acoustic leak detection, this will be on the right-hand side of your screen right there. I'm just taking a 500 miles of pipe system for an example. And so without the satellite-guided leak detection approach, excuse me, if you're doing a point-to-point survey, you're truly walking that 500 miles of pipe right there. And honestly, probably spending a lot of time in areas where nothing's leaking at all. Now, with the satellite-guided approach, just with one scan of the system and through the benchmarks associated with that method, we usually see between 5 and 15% of the system highlighted with these points of interest. And so, for example, instead of having to walk 500 miles of pipe, now we're going to get data that's very informed where potable water is already leaking in the soil, and that's going to be around 50 miles of pipe. And so you can already see the drastic increase in efficiency there. Now we're focused on specific areas of pipe and sections of that pipe where we already see the water leaking right there. So now I'm going to toss it back over to Paul real quick to go through some of the metrics and how we can really compare leak detection performance and the different methods as well. So Paul, take it away.
Great, thanks, John. So benchmarking and metrics. I first began work with Asteria in 2015. At that time, they were unique in that they triaged the system and identified likely leak locations or points of interest. And then they used their traditional boots on the ground field leak inspectors to do the pinpointing using field level acoustics. So this process was not like anything else on the market. Performance metrics were needed so that it could be accurately described and compared to other techniques. SILD, or remote Earth observation, was new to the marketplace. There was a steep learning curve regarding how the solution worked and how it compared to other systems. So the first performance metric we developed was just the total number of leaks. But this was dependent upon a lot of things, including capital investment, and the amount of staff time allocated to looking for leaks. We then moved on to leaks per point of interest. But this metric was not comparable to other processes because no one else generated points of interest. No one else triaged the system to minimize the amount of pipelines that were to be analyzed, as John mentioned. The next iteration was leaks per crew day and leaks per miles inspected. Leaks per crew day evaluated the ability of the boots on the ground to find the leaks and pinpoint them. The leaks per mile evaluated the ability of the Astera algorithm to successfully identify leak locations. The success of the SILD program has two parts: the ability of the satellite to find the likely leak locations and the ability of the boots on the ground crews to pinpoint those leaks. But this was really not what utilities were concerned about. You all wanted to know how many leaks were found and how much water loss was reduced. So we began to look at types and sizes of leaks. Turns out that the main pipe leaks are typically larger than service line leaks, which are larger than hydrant, valve, curb stop, or meter leaks. Estimating leak size is problematic. So we use data from AWWA Manual M36 as a baseline. Estimating the time a leak has been active is also problematic. We must also estimate how long a leak would go on unnoticed if no proactive program was in place. These were used to calculate water loss reduction and dollars saved. Using this data, we could identify how much leakage was reduced per crew day and thus per dollar spent. This then led us to value metrics like return on investment and reduction of non-revenue water. Next slide, please. Now let's look at the comparison of the traditional boots on the ground and the Astera performance metrics. In order to analyze the value proposition of the Astera program, we can look at the baseline traditional boots on the ground. This is the standard way of executing a proactive leak detection program, sending out crews to go from one end of the system to another and trying to pinpoint leaks. As you can see from the table, the traditional method data was collected from over 2,000 projects from two different construction vendors over the last 10 to 15 years. More than 18,000 leaks were found in those two programs, and the performance realized was 1.3 leaks per day and 0.3 leaks per mile. The average leak size was 3.2 gallons a minute, and the average cost to find a leak was about $1,250. For Astera, over 1,200 projects were analyzed, with over 191,000 leaks being found. The performance was 5.5 leaks per day and 3.4 leaks per mile. The average leak size was 4.5 gallons a minute, and the cost to find the leak was about $700. One important fact that was discovered is that leaks are not evenly distributed through a system. They're clustered. It's estimated that 50% of the leaks in a system are contained in 10% of the length. If you can find the leak clusters, then you can be more efficient in pinpointing and fixing leaks. This is the real benefit of the SILD approach. It can focus the field inspectors on areas where there is a higher likelihood of finding a leak, making the crews more efficient. So now I'm going to pass it back to John to discuss what else the remote Earth observation platform can do.
Amazing. Thank you, Paul. Yeah, so like I mentioned at the start of the presentation in the agenda, many different applications that can be used actually with the exact same technology that we utilize, which is synthetic aperture radar, like I mentioned. And so in addition to not only just potable water leak detection, we can actually do wastewater detection as well, utilizing the same technology. And also we can now start to look at potential areas of, say, seepage, internal erosion, and also potential risk areas throughout earthen dams, levees, and canals as well, which is what you're seeing here on the top right of the screen. We're actually now starting to make it a lot more actionable with that solution right there in terms of making it kind of more SCADA-like in terms of having alerts and alarms based on the amount of soil moisture that we're seeing in these specific areas around those dams, levees, and canals right there. So now I want to take some time to hop through a few case studies that we brought forward for you guys today, all using the satellite guided approach and comparing really how they were doing it previously to how they're doing it now with the satellite guided approach of leak detection. So this first case study will be with New Braunfels Utilities in Texas. They're about northeast of San Antonio and serving about 60,000 plus customers right there. And so a little background, in 2018, they had about 18% non-revenue water rate. And really at the end of the day, what they wanted to do is, of course, get that down. And so one of the very cool backstories with actually New Braunfels is that they were already being proactive within their efforts and leak detection efforts for the 5 years leading up to their decision to look for a more data-driven approach. And so between that 5-year period leading up to 2018, they were surveying 20% of the system each year. So it actually took them 5 years to do the system just one time over. Now, one of the direct benefits of a satellite guided method to do so is that now in 2019 and beyond till today, they're actually doing 4 scans of their system every single year. And so now they're able to analyze their system 4 times every year, catch new leaks that arise, and also catch the small ones before they persist into those bigger breaks that, of course, always happen at the worst time over holidays or at 2 o'clock in the morning. So being able to catch them before they persist in those bigger ones is really crucial. Now, looking at the comparison between MBU's efforts in 2018 with a satellite guided approach in 2019, you can read the numbers on the right-hand table there, but I'll just go through some of the increases in efficiency here. So about 6,733% increase in leaks found per day, 77% decrease in crew labor days used, and also the crew labor cost reduction was $130,450 as well. Now, their NRW was ultimately reduced to 10%, with over 994 million gallons saved over that 4-year period right there. Alrighty. Now, I do want to go a little bit to um, the east. It's Tennessee here. And so this is a utility based in Madison, Tennessee. This is Madison's Bourbon Utility District. And so they're just 10 miles north of Nashville. Smaller system size in terms of miles of pipe compared to MBU, but actually serving a little about 10,000 plus more customers. And so a little bit background with MSUD and why they decided to go to a more data-driven satellite-guided approach to leak detection. First and foremost, limited staff. I would say limited staff, high NRW, and also just trying to see how they can make the best use out of their time in the field. I think they have maybe 1 to 2 leak detectors on staff. And so, of course, I'm sure as some of you also have in your utility that leak detectors also can do many other things in the utility. So being able to really focus their time and effort through the satellite-guided approach was a very huge benefit for MSUD. And so they actually started off with us at 45% water loss. And of course, that was really their main kicker to really go and reduce that. So on the right-hand side, as you're seeing with the comparison between traditional boots on the ground and the satellite guided approach, they were able to find 2.5 leaks per crew day compared to the 1.3. What I think is the greatest metric here is going to be these leaks found per mile and also miles walked per day. And so they were able to find 2.3 leaks per mile, but also only had to walk about 1.1 miles a day to go out and find these leaks. And so that really shows with the satellite guided approach, we should be able to, one, find more leaks per day, find more leaks per mile, but also we're going to walk less miles to do so. So compared to the benchmarks, that's a 92% increase in leaks found per day, a 597% increase in leaks found per mile, and a 71% decrease in miles walked per day. Now, also with the satellite guided approach, really the name of the game is those non-servicing leaks for you guys. Most of the time, you're going to know about the servicing before the satellite guided approach and method can do so. And so we're really going after those non-servicing ones for you guys. In this service alone, 95.5% of those leaks were non-servicing. And after the investigation, of course, the repairs were made. Ultimately, it reduced our non-revenue water from 45% to 26% currently. And so that equated to about 113.5 million gallons of water a year saved, and then around $227,000 of annual water cost savings for MSUD here. Alrighty, now I do want to go all the way to California now from Tennessee. So we're going to now go talk about San Bernardino Municipal Water Department. And so this is a utility, biggest utility we currently work with actually in these 3 case studies. So we'll be serving 200,000 plus customers in San Bernardino, California, and also the surrounding communities with 700 plus miles of pipe in their system. And so why did San Bernardino come aboard? And why did they look for the data-driven approach? First and foremost, really it was a regulation set forward by the state to reduce their real water loss by about 54%. Now, of course, it seems like a huge number, but actually we were able to get it done for them. And looking at really the satellite guided approach, and you can see the direct increase in efficiency on the right-hand side of the table right there. It's actually very good and very big increase in efficiency. With California, of course, having that 10% water loss regulation, now we're able to make it a lot more efficient and really get that reduction down very efficiently and quickly as well. Now, with the traditional boots on the ground, as you guys have seen those metrics, about 1.3 on the per day and zero 0.3 per mile. With the satellite guided approach in San Bernardino, we were able to find about 5.5 leaks per day and 7.3 leaks found per mile. And so, of course, like I mentioned in the previous case study as well, more leaks per day, more leaks per mile, less on the labor, less time in the field. So comparing those to the traditional benchmarks of the traditional boots on the ground, that'll be a 300% increase in leaks per day and a 2,112% increase in leaks per mile. Now, of course, their main goal was to reduce their water loss. They had that regulation to be reduced by 54%. And ultimately, they were actually able to reduce their real water loss from 49.8 gallons per capita per day to 17.9 gallons per capita per day, which was a 64% reduction. So we're actually able to achieve 10% more than they were actually required to do so. And so one of the benefits of course, being able to triage the whole system multiple times and then focus the efforts into areas where the water is already leaking. Amazing. So I know we have about 10 minutes left for some Q&A. So at this time, I just want to let you guys, of course, ask some initial questions here. I'll leave this up for about a minute or so in case you want to have any of our information. And then just some housekeeping items as well. You'll actually be sent the recording of the webinar very shortly after this. And so if you want to see that or any of the reporting where any of this data came from, please don't hesitate to reach out. I'll be more than happy to provide that and or any of the case studies associated as well. And so, like I mentioned, you do have a spot for Q&A at the bottom here. So if you guys have any questions, please feel free to ask away. I'll give about a minute to kind of kick those off, and then we'll get the ball rolling. I'm going to open this real quick. Amazing. All right. Got one question here from Will. So appreciate the question here, Will. And so this one I'm pretty sure is going to be directed towards the satellite guided approach. And so the question here from Will is, what are the smallest leaks in GPM that you are able to find? And are you able to find surface line leaks? Well, and to be completely honest, I think that is our bread and butter right there is going to be able to find these small to medium sized leaks for you guys. Of course, we're going to run into the big one here and there. But at the end of the day, I think you guys are probably going to know about those before we do if they surface for sure. And so we can find any leak that's actually 0.2 GPMs and above, as long as it's been leaking for about 72 hours, just so it saturates the soil enough for us, for our algorithm and the satellite to pick it up right there.
One thing, John, I would add to that is
Yeah.
that the system can also identify leaks on the customer side of the meter. You might want to go into that a little bit.
Yeah, 100%. And so with the satellite guided approach, like I mentioned, we do have those POIs, and so those POIs are about I would say a block range. And so with that being said, we see water in that area, but like I mentioned before, we don't see the origination point. And so just best practices when going out to investigate, we want to hit every single asset and listening point within that point of interest to make sure we capture everything. We'll go into many POIs where we see two server side, two customer side leaks, get those addressed. We'll go back to it, investigate, and then here you go. You got a service line leak as well in this POI. So, like I mentioned, we see where the water is accumulating, not where it's originating from the point of interest. Amazing. Thanks for that, Paul. So, I got another question here from Maggie. Thanks for the question. Any issues with parked cars over water mains and subsurface rock formations? So, directly with the satellite, short answer there is no. In terms of subsurface rock formations, that would more come into fact on the portion of the investigation. So like I mentioned, Astera is kind of that first triage approach. The satellite guided is the first triage approach, and then the investigation is kind of where those rock formations would come into play. For example, that's actually one of the things that we have with the limestone in Tennessee is that the leaks are going to fissure out. They're not always going to be right with the origination point. Then we might find that soil a little bit further down the road. And so we kind of just use our best. We'll work with the utility at that point, but maybe look some topographic maps as well. Because for example, if you got subsurface rock formations and we produce a POI on the bottom of a hill, like hey, we may want to check the pipe on the top of that hill right there because it may just leak down into it. Amazing, amazing. Alrighty. So we got a question here from Michael. Does any equipment have to be installed or just the satellite imagery? And so it's one of the best kind of benefits of the satellite guided method to do so is it's completely pipe agnostic and completely non-invasive. So we need nothing in the ground in order to attain this data. So we're able to attain the data really from any point in time. It's also completely weather capable and day-night operational. And so yeah, just no equipment at all to be installed. Amazing. Got a few more questions here. Got a few from Michael again. So typical ROI, Michael, is usually under 12 months for us, I would say, almost all the time. And so rough cost, I would say, just really depends on the utility at that time and how many. So it's based on the miles of pipe in the system is what the price will be based off of. And so very comparable to traditional kind of methods of leak detection on that side.
John, just one thing
Yeah,
about the return on investment.
100%.
Keep in mind that, we kind of know the rough cost of, how many dollars it costs to find a leak and then the size of the leak. So the ROIs tend to be driven by the cost of water production. So what is that incremental cost to produce a gallon of water and to deliver it into the system? In areas where the cost of water production is low, less than $1, you're going to have longer returns on investment time periods, simple paybacks. Where areas that utilities are, say, purchasing treated water from another utility, and so the cost of water might be $4 to $5 per 1,000 gallons, those return on investments are going to be a lot faster. So it really depends upon your cost of water production.
100%. I got a quick follow-up question for you there, Paul. Would you ever look at the price of the revenue water for an analysis like that, and potentially the opportunity cost what we're losing on that side of things?
So that's interesting, because if you look at the price that the customer is paying, that's not really a value to the utility. It's more in that particular case, say if you find a leak on a customer side of the meter, and you can identify that, then it's more of a value to the customer than it is a value to the utility. At the end of the day, if the goal is to reduce water losses, just in general, not necessarily a financial driver, any water you can save is going to be valuable. There's a lot of places in the United States that have water supply issues. And if you can reduce that, it is, in essence, finding leaks, reducing water loss is, in essence, another way of increasing water supply. And it's actually the cheapest way to increase water supply. So if you're in a water-stressed area, the value proposition can be financial, or it could just be, a safer, more reliable supply. So there's lots of different value propositions for finding leaks.
Amazing. Thanks, Paul. All right, I got another question here from Raul. Thanks for the question. Do you ever do a simulated leak where you let water run from a hydrant or other feature to create a reference leak? It's a great question, Raul. Actually, funny enough, that's actually how we really tested out the technology in the first place. So we knew we had the technology, and how we were able to test it out is we actually did that. And so that's really how we were able to test out the technology right there. So currently, we don't really do that right now. There's option potentially, but that's really how we tested out all the technology. And so that's how we're able to verify everything right there. From Ramiro here, I got one. What is the average distance between a POI versus the actual leak location? And to be honest, it completely varies. It completely varies on where you are. Like I mentioned, if you had that subsurface rock formations, it might fissure out to a different area. Maybe it's a listening point or two outside the point of interest. But I would say 95% of the times, it's going to be, or Ramiro, it's going to be right inside the POI right there. All right, got another one here from Ramiro. I got a few minutes left for you guys. If I don't get to your question today, I'll be sure to get that answer to you over in an email right after this call. So from Ramiro, again, what is your typical project timeline from mobilization to delivery? That's a great question right there, Ramiro. So satellite imagery detection, one of the benefits as well, it's fairly quick to require, and we have very frequent coverage over the Earth. And so we can get a new image about every 7 to 14 days. For us to analyze it, get that back over to you, I would say it's about a 2.5 week turnaround time for you right there. In terms of when we can make that actionable in the field, um, we have option as well to use our team to go out there and help you guys do the investigation if you don't have the means to do so. But as soon as we get that data over to you guys, really it's actionable at that point and we can hit the ground running. Amazing. So it looks like I got 1 more minute left. I'll take one more question. And I think the question I have right here, perfect. Yeah, so this question is basically, is there any limitation to the technology in terms of what you guys can penetrate through? And so with the satellite imagery detection approach, we can penetrate through really any material that's going to be above your pipe. And so we're talking about asphalt, the clouds, any agriculture. We're able to get through all that, see subsurface about 10 feet in that soil for you guys. Of course, if it's drier, maybe we'll go a little deeper. If it's a little more clay, maybe we'll be a little under that 10 feet, but with the US usually having their pipes above that, we should be all good. And so really we can penetrate through any material, so asphalt, concrete to clouds, pavement, really anything like that, forestry, you'll be able to get through there for you guys and still see these leaks. So of course, one of the benefits as well is being able to also find leaks in hard to access areas, utilizing the satellite guided method. So. But alrighty, guys, I know I have a few more questions I didn't get to answer. I'll be sure to get those answers to you guys today. But I just want to take this time to thank everyone for joining. It is at our time today. I want to thank Paul very much for hopping on and giving the presentation. And then also, like I mentioned, just last housekeeping item here, you'll get the recording for the webinar right after this. And so be on the lookout for that. And yeah, thank you again, guys, again for showing up today. Look forward to connecting again in the future. Have a great one.